Well, hi, good morning. Thanks so much for joining me in my shop. Today is October 17th, and another rainy day here. So, shop time, good time. And it's going to be a good time because I'm going to be focused entirely on the coil I found yesterday that certainly seems to be open circuited. That's this coil here. I'm pretty sure it's this winding on this form. And I'll just show you on the schematic where we are. So we have the antenna transformers, then we have the intermediate transformers. Not a good thing to call this. The RF, we can call these the RF transformers, and these are the oscillating transformers, oscillator transformers. So we're in this bunch here, and it'd be this coil here, right at the bottom, pictorially. The little one. That one. It's like the first. So just an overview of trying to fix this. Oh boy, if I'm lucky, I can do it with the coil right where it is now. If I'm unlucky, this whole thing has to come out of the radio. Okay, that's being really unlucky, because taking something like this out of a radio, like all these coming out, getting them back in, and having it all work afterwards, that's not a simple matter at all. So I'm really anxious about this, frankly. I'm just hoping. My guess, I'm going to take a guess. My guess, what happened was this coil got damaged while work was going on up in here. And it could be my predecessors, we don't know how many other repair people have worked on this radio. Or it could be me. This could be a recent thing. I may have popped that coil open accidentally. So if that were to be the case, you would expect to find some damage kind of up on the top here from soldering iron strike, or I don't know, something. Another really good possibility is bad connections at these terminals. I'm pretty sure these are the two terminals for the ends of the wire that's in the coil here. And we'll take a really close look at these. In the past, I've found these corroded a little bit. You've got a mixed metal system there. You've got the solder, which is a mixed metal to begin with, right? It's lead and tin. And then you've got copper. Electromotive force between lead and copper is a little bit significant. So if you get enough moisture in there, you get a little battery thing happening. And since and who would win? You know what? The copper would win in that kit. In that situation, the copper would be protected and the lead would corrode. But I've certainly seen radios with bluish corrosion on the copper wires. The thing about these wires is, like, look, they're really, really thin. So a little bit of corrosion goes a long ways. Let's take a look, because I think we may be able to just see this. We may be able to just see this. So first, I think I'm going to take a look at the coil terminations here. The terminal. So this is the top terminal. Well, you can see the wire. Can you see it in the solder pool? Looks like it comes. So the normal thing that they would do is the wire would come off the end of the coil, and they would wrap it 2 or 3 times around the post here and then snip it. And he might reach with his finger, push the snip part down, and then solder. And maybe that's what we're seeing there, the snip part. I'm looking for the wraps around the terminal. I don't see any wraps. So I don't see, all I see is that little piece of wire there. Huh. And there's nothing else connected to this terminal at all. Like, there's no wire hooked up to it. Oh, what good is the terminal with no lead wire? And this one, let's look at this one here. The other one. Well, that's interesting. Okay, so you can see the actual lead wire from the form. In fact, you can see where the wires drop through a hole. One wire, anyway, drops through a hole there and heads to that terminal, no doubt. And that seems to be, looks like it probably wrapped it around the terminal. Let's see if I can get down this way. Yeah, you can see you just kind of brought it out. does it get back? How does it goes in the hole and comes back out? Goes in the hole. Goes in the hole to hold the wire up here on the actual. Is that the spot right there? Okay, let me put this dead center of the screen there. There's a light flash on it. I'm gonna have to get. Look at that. Looks like the wire's open right there. Doesn't it? Right where? Yeah. Let's see if I can point to it here. Right there. Right there. There. Well, either the insulation is kind of flaked up there, or the wire's popped open right there. Huh. Man, that'd be great, because that's right in front of the coil. I mean, I can fix that without taking it out. Let's go back down here again. Finish what I'm doing. Finish what you're doing. You're looking at the terminal. So, you know, I could just resolder that. You know, just heat it up, melt it, and solder it, and that might, if there's a problem at that connection point, that would do it. So, you know, same thing up here, except we can't actually see the wire. So this would be the other end. This would be this end. Oh, what's that? So the turns are disturbed there. Do you see that? Oh, let me try pointing to it. I'm sure you can see it. It's right up in here. So now that looks like something that got done while work was going on below. Like it got. So I don't know. Is that actually open circuit there? Doesn't really look like it. I'm gonna have to get my microscope out and try to get some really close looks at these things. Actually, a lot of wire to look at. Well, that spot looks really suspicious there. That first spot. Don't know how I can inspect this all the way around. Okay, let me see if I can get a more powerful magnifier going on this. Let's see if we can get a closer look at that coil. Okay, so this is my microscope here, which I'm going to give a shot at doing a close-up of the coil. The frame rate is very slow on this. At least today it's very slow. So it's a little annoying, but let's see if we can get something on there. Okay, so I'm going to start with one of the terminals here and see if... the other thing that's annoying is the image is flipped. So that makes it tricky for me to... So there's what we were looking at to start with. Doesn't it look stretched left and right? And there's the wire dipping in the pool. Okay, that's really not what we're terribly interested in though. So there's the other terminal. And there, yeah, now you can see fairly clearly. There's the wire wrapped around the terminal. It doesn't look very soldered. You can see it in the bottom left there. It really doesn't look like much solder on it. Okay, now the main act here. What about that hole in the wires? Okay, let me just try to get it focused here. Good, there. Okay, now the hole should be kind of in the bottom left part of the camera image, I think. No, this is backwards. It's backwards. It's on the right side. There it is. Right side in the corner up there. It does look like a break, doesn't it? It looks like so the two wires to the right of it appear to be moved leftwards. You know, something struck this coil. So the next stage is to pick at that and see if I can pick those wires right out. Okay, so I just moved the light a bit, and now the break is quite visible. Right in there. Oh, man. So there's no hope of me. What I'm doing is I'm watching the screen right now. can't imagine I can succeed in doing this. Wow, okay, wire is really loose there. Oh, look at that. Definitely. Huh. Okay, so now we know exactly where at least one break is, and probably that's the only break. These things should break a little like a chain. You know, pull a chain too hard, one link breaks, not the whole chain. So, you know, that's on the front face of the coil where it could take a knock. That's probably what happened there. So now what I have to do is I have to pull out both ends, clean off the varnish or whatever coating is on there, solder a tiny bridge across it. Do this without damaging the rest of the coil, and we're done. So and I can do that in the radio. Like I can leave the coil in the radio. Hot diggity dog. That's what I say about that. That's a great thing. So for sure I'll take this panel out here. I'll go this way. I'll take this panel out. Which I spent a long time putting these in, by the way. Because I'll show you, this will come out pretty easy. Didn't go in easy. Oh, right, the band switch. The band switch shaft is a flat piece like this, and as you rotate it, it eventually gets like that, and then it can slide out the slots here, or the. Oh man, I just freaked myself right out because I saw this audio meter down here flip, and for a moment I thought it was this one, and for just a second I thought the radio was on. Oh man, you want to feel a shot of. Adrenaline, that's one way to do it. Let's go around this way. There we are. So now it's this way. Out she comes. Yes, these things are so precarious here, this arrangement. Okay, I put together my bundle of spacers and washers. This is what took half an hour, was finding just the right spacers to put on. I don't dare tighten these nuts up or it's just going to rip that little screw piece right off, and then I'll have another project I don't want. Take a little better look at the let's take a little better look at the coil now. I have a little better access to it. I'm just going to grab the camera this way. Kind of get a look at the end of it now. That's kind of a weirdly shaped. One like that? No, this one has this big heavy wrap of look at the debris in there. I don't know what that big lug is all about there. Looks like it has something inside the coil. I don't expect so. Two coils are right here. The transformer primary, secondary is right there. I don't imagine anything's inside. I don't think inside a coil like this, I don't think you get the magnetic effects you need to do transformation and stuff. You can't put one inside the other, I don't think. So anyway, there we are. So pick the other wire out, clean them off. This is like a to do this a little like a clean room sort of operating room operation here. You can see it quite nicely, but you know, it's tiny, right? This is tiny stuff. Tiny stuff. Okay, so I'm going to try to pick the other end of the wire out if I can. Oh wow, it's really hey, now I got an idea here for me. This is my idea here. Let me just get something off my pegboard. Look at that. Let's give this a try. I don't use these very often. But these are definitely going to help. Oh yeah, these will help. Use the right end of the pin. Okay, get the other end of the wire up. Oh, you know, I can jab that coil with this needle pretty easily. Swing him over here where I can get at him clearly. Excellent. Excellent. Okay. Now, I'll show you what I've done here. I mean, it's no big deal really. I've just swung the wires off to the side so I can work on them. So a couple things you can do. One is you can take a lighter, you know, and put a flame on these wires and burn off that insulation. I personally wouldn't try that because the next thing that happens is the wire melts and melts back suddenly, and so you lose your length of wire here. We don't want to shorten these at all. So the next way, the only way I know, is to kind of scrape it off with a X-Acto knife, that kind of thing. And just scrape away. We don't have to make much of a connection to succeed here. This coil is going to carry a few milliamps of plate current. It's got to be good enough for that. So, scraping. Let me just fiddle with the cameras here for a moment. Now, I may just, you know, block the camera with my hand or something while I'm doing it, so it'll give you at least some idea what I'm up to here. I want to hold the wire in place. I'll be able to see what I'm doing here. Hold the wire in place. And then just believe me, I can't see if that's having any effect. Oh, I think it is. So what I'm looking for is a change from the kind of reflectivity that you see here to the metal sheen. Right, the metal sheen is what you're seeing up on here. That's not very good, actually. And that's what I'm trying to see. Huh. Not so much on camera, but just looking with my eyes. You don't even have to get this stuff off all the way around. You just need enough surface here to do the parallel thing. Okay, I think that's about it. I think that's really about it. Now I'm gonna get my finger up here. How am I gonna do this? So I don't want the blade to pull the wire out of the form any further. Now I gotta get the blade more right angled onto it here. And now I gotta be able to see what I'm doing. I think I'm scraping the wire. Look at the camera. Quite a good view in the camera, but my eyeball view is not so good. Where'd the wire go? I can't even see it. Oh, it's way down here. So this is very delicate stuff. It's worth it to just go very slowly, and because the potential for the problem to get bigger and bigger is very high. You poke more holes in the coil and break the wires more, that kind of stuff. I got this sharp blade right near those coils. Was I doing anything? Where'd the wire go? There it is. Wow, it's so hard to see without holding it. Nope, nope, nope. Just gonna pull it away. Oh, wait. So I don't think that bottom one's shining yet. Let's see. Okay, hold on. I gotta do this on. So I'm gonna put on those magnifiers. I gotta get in really close for them to work. Oh, that's a lot better. But man, am I ever jammed in here? Okay, no idea what you're seeing on the camera. You know what? There's bare copper there and bare copper there. That's probably enough. over here. Now I got to somehow solder a bridge across those. So I need a nice piece of wire to do it. Okay, let me get things together to try that out. There. Hey, you know what? That's going to do it. Right there. That's enough. Don't poke with it too much. Okay. Whew. Next step. Soldering iron. Oh my gosh, wrong camera view. I'm sorry about that. Son of a gun. Okay, I'm sorry about that. I missed the exciting part where I soldered it. Well, we'll do a resistance check first. Sorry about that. I whipped this camera aside and then didn't change cameras. So, I don't want to cut away the copper or the excess copper wire yet. So I think there's a good chance this didn't work. Oh my gosh, cat. What are you crying about? What's the problem? You want to come in? Come on in. Come on. They're all the same. Yeah. She won't come in because she wants me to go out. That's what she's saying. I'm going to ignore her a little bit longer. Probably can't get away with it much longer. Ohm reading. Here we go. This is the test. This is the first test anyway. Just set that there. Terminal to terminal. First, check the meter. Looks like a no-go. Okay, now check it into the middle of the joint here. What's this mean? No go on either? Really? What's going on with the contact here? Well, I'm jumping in at this point. I'm actually editing that video you're watching, and I've just stopped and jumped in here. I am not going to include about an hour and a half's worth of poking around following the work you just saw me do, because it was really based on confusion. I'm just going to jump right to the situation. This isn't the only open coil. There's another band with an open coil, which I didn't realize until about an hour from this point in time. So I'm going to try to skip over all kinds of nonsense in between, in which I'm confused about which band is working, and all kinds of stuff goes wrong. I'm just going to jump right near the end where everything starts going right again, and you'll just have to kind of imagine me really losing it here for an hour and a half with Tess saying one thing and then saying something else, and oh my god. But so I'm just going to skip over about an hour and 20 minutes of torture. Well, you know, I gave that little analogy of the chain. When you pull on the chain, only one link breaks. But you know, I saw another broken link in this coil, and I've ignored it since I found the one in the front. And that's the one up in the back here. I just started assuming that was probably not important. Maybe there's 2 brakes in this coil. I'm having a very hard time steering the camera. That's what's happening. That's the area right there. Oh, come on. It's well, oh, I wish I could. You know, it does not look broken to me. I'm struggling with the reversed image, you know. Well, really hard to say there. And you can't pull a wire out. It's either got to stretch or break. Man alive. Let me just get set up for another picking session here. Okay, I think I'm ready for an attempt to pick out the loose end of the wire if it's really there. I've got my bi magnifiers on here, but I cannot look at the screen. I'm looking through a magnifier. Wow. See clear enough here. Okay, so let me look up at the TV screen here. Oh, there. Looking up through my magnifiers. That didn't work. Okay, I'm all cross-eyed here. Hang on a second. More light on that. Better light. More and better light. Okay, so it's taken an awful lot to get this shot here of the area that we're concerned about. And boy, that's really hard to tell if that's broken there or not. I mean, it kind of looks broken. Now, can I get a pin in there? Oh my gosh, I don't know. I don't know. If I can get through all this to get at the coil. Let's see. If I just touch that camera, it's going to be out of focus and everything here. Oh my gosh. Okay. Boom, right there. Right there. Okay, I gotta change the angle of the needle a little steeper coming in. It sure looks broken now. Right there. Ah, it's very hard to do this. This camera's reversed again. How many times I'm going to say that? Up is down. Down is up. Oh my gosh, left is right. That's what's going on here. Left is down. It's even worse. There. Right there. Okay, so what happened there? Did I prove something? It sure looks like the copper stops right there. And then you might have the insulation, just insulation between the gap there. It certainly is connected though. I mean, mechanically connected. Wow. How am I ever going to prove this is an open circuit or not? Wait a minute, whoa, 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 whoa. Hold the fort. Back up the train here. I've already proved that this is, there's continuity through here. I have proved that, haven't I? Haven't I already proved that? Well, it's taken me a long time to get this camera shot on that same spot. From this angle, boy does it look broken. So I'm going to try to poke in there again. I won't do it live on camera because I'm going to have to move the camera, and then it's going to take me another hour to get it back into place. So, but that really looks broken there, doesn't it? Yeah. Okay, so I've tied my microscope camera into the radio there, just the right angle to get this view. And now I'm going to try to poke at that wire again and see what happens. So I poke one end. Oh my gosh. Wow, look at how sharp the bend is right there. I'm tempted to break it. Sure seems to be connected though. Wow. I think that if that were actually a broken wire, it would separate by now. I'm heaving right on it. Oh. I don't think that's a broken piece of wire. That's disappointing. I need a broken piece of wire. Didn't I already prove that this is continuous here? Oh my god. Okay, so just going to touch the terminal here with my ohm meter. And jeepers creepers. Yeah, I've been in here way too long. Trying to contact the open end of the wire that I could see in the camera. I expect just the numbers just to flick here. Just any flick. Nothing. Didn't I say nothing and then suddenly something? I saw it. It's really hard to make contacts here. Just double checking. You know what? The wire's off down here, for crying out loud. Ah. Well, there's a good shot of the wire that has. I think it's broken off. I don't think it's separated from the solder blob there. I think it's broken. Son of a gun. Wow. So I have to scrape that again, and then. Oh boy. This is a really tough go. This is a really tough go, this one. It would be a little easier if the coil were out, but that's not high on my list of things to try. Okay, so I've got to get at the wire here and scrape it again. Okay. quite good, like just like that. If I can solder it now. Good question. Let's see. I have it, but man alive. Okay. Now, there's a chance that has actually fixed the coil, that there was a problem there and they didn't know about it, and that's fixed it. So we need to test the resistance of the coil here. What's that? Oh, calm, cool, and collected. That's what's going to work. Did that just show the coil to be continuous, or did I just contact a contact that's contacting a contact? They're different terminals. Different terminals on the switch I just tested between. Resistance from plate pin back through the coil. Plate pin 3. Either side of the coil. One side is down here. Don't see anything happening. The other side I think is here. Why they come and go? Oh, careful, man! You're gonna have another hole. 2,000 ohms. And the other terminal, show me a 0. Same thing. You son of a gun, you. Long shots. Broken wire. Other end of the broken wire. Everything reads 2.3K. What's the deal with that? Is that the coil resistance? This can't be 2,000 ohms worth of wire here. How do you get that? Because I think it's straight from the plate. Straight. The right tube. Straight from the plate. Straight to the coil. We should get a 0. Stupid situations. Okay, now the whole thing I've been doing for the last hour might have been bogus. I'm certainly on the shortwave top band now. Got a clip through the meter, through the coil, through the coil. Son of a gun. So another line of attack here on this coil. Open the, turn the band switch and watch for the resistance to disappear between bands. Or the lack of resistance. Open. Closed. Whoop. Oh. I gotta repeat the B plus test. So I have a clip on already. We're kind of set here. Let me just switch it to the red probe so we're... Yeah, right. Yeah, what time is it? It's 12:20. Oh my gosh. I try to spend 2 hours or so in here each day, and it's not going well. Not going well. Okay, pin 3, voltage to chassis. Voltage to chassis. Well, that's resistance. Well, that just freaked me right out, that's for sure. Okay, we're going to energize, and we're hoping to see B plus show up here. You know what? I got to take this camera out of here. Wow, I'm about to turn the set on with this thing jammed in here. Yeah, I better get that out of there. Any other goofy things in there? Don't think so. Okay, power on. Here we go. B plus. Show up on that meter. Oh my gosh. There it is. Oh my gosh. 428. Wow, that's really socking it to the radio now. There's supposed to be 200 on this line. Now I've changed the rectifier tube from the 5U4 to a 5Y3 in hopes of dropping the voltage down a bit. But I did this once before, it didn't make much difference. I don't think it's made much difference here either. What would make a difference is plugging in the 245 tubes and getting that draw onto the power supply. So unfortunately, we're still pounding this radio with too much B+. It's probably why these resistors up here continue to get a little hotter than they should. Good. Change bands. And watch this come and go, but always, or let's say go and come, but always come back. In 4 spots. Okay. Because maybe I got this band switch stupid spot again. Okay, we're at 1 amp. Here we go. Off and back on. Off and back on. Boy, do I ever get this messed up. Maybe I'm getting it messed up because there's 2 open coils, 2 open deals here, and I'm switching between them. Maybe that's part of it, but there isn't. There's only 1 open. You're not making any sense, Jim. You're not making any sense anymore. Senseless situation here. Yeah. You know what? Maybe this isn't so senseless. Maybe, because the long wave bands seem to be kind of dead, and the high shortwave bands seem to be dead. We've been working on the high shortwave band. The radio is definitely switched to the long wave band right now, and there's no B+. So let's revert back now. Okay, and I'm really quite sure of this. So this would be AM, and we get B+. This would be the lower shortwave, and we have B+. Oh, you can't even see that. For crying out loud. What a situation. And keep turning it the right way now. This is the high shortwave band. Beep. What did I do? What did I do? So I got this turned around the wrong way again. Yes, that's long. This is how it happens. That's long wave. This is how it happens when I'm doing it. Here we are. This is the shortwave band. Look at that. So you know what's happened here? I think I've made the repair and then got confused about another open coil on the long wave. So I think this radio is working on shortwave right now. Okay, let me kill the power and we're going to test it to see if it really is receiving. No. Yeah. Let's do that, and then I'm going to permanentize this repair here if it is in fact working. Power off. You know, boy, I tell you, just about every radio I work on, the band switch throws me for a loop. Can't handle that band switch thing. Okay, just make sure the power's off. Pull this out. Audio. You know, I didn't have to turn it off. I didn't have to stop the video. Let's turn it back on. Turn it back on. What I need to do, let's just move this light here. Oh boy, my shop is a mess. Okay, let me get the headphones on. I'll turn up the sound so we can hear what the radio is doing, if anything. This is a big moment here. Let me put on headphones. Volume on the radio is up about halfway. The antenna consists of the lead going to my signal generator. Signal generator is not switched on or anything, so El Crapo antenna. But let's just see what this sounds like now. Volume up over here. No, that's not really what I'm hoping for. What I'm hoping for is some hiss and stuff. Let's turn it right up. Let's put a better antenna on it. Turn it down a bit. Oh, I think I might have heard something there. I think I might have been hearing the hiss. Now we want to hook up the antenna over yonder. So we should start hearing something, even crackling when I do this. I heard any crackling there. Volume up. Oh! Well, that sounds like a radio. It's 10. Funny stuff going on. Definitely funny stuff going on. Let's turn it back up this way where we can hear something. Doesn't sound very good. Okay, let's get the signal generator going here. Okay, antenna off. Signal generator on. High band, somewhere on the high band. Okay, so the capacitor is mostly, plates are separated mostly. Somewhere around 10. 10, 6, 12, yeah. Fairly high level signal. Volume up. Volumes are all up. Everything's up. Here we go. Run that way. So I gotta change bands. Okay, here we come. We're in the range now. hung down. Okay, well, despite the enormous amounts of confusion I've been through here, doesn't take a lot to confuse me, obviously, somehow I've managed to repair that coil and discover at the same time that the long wave coil, something I don't know for sure it's the same. I do know for sure it's the same coil. It's got to be the primary coil. So we can take a guess here. Let's take a guess. There was a problem in the radio causing far too much current to flow through these primary coils to the plate of that tube. Somebody turned the radio on, coil burns out, radio's dead. Switch to the next band, burn that coil out, radio's dead. Switch to the next band, and the radio's not dead because the coil can tolerate the current. I don't know. I know this. If you've got a coil burning arrangement in your radio that's burning the primary out on these things, and you switch the band, you could just burn one coil out after the next. And this is a very serious problem with one of my military radios. I'm not sure which one it is. I think it's the Hammerland, that under certain conditions it will burn something out, and as you switch through the bands it just burns them out again and again. I can't remember what it was that burns out. So there we go. Radio's working. I'm stopping for today, and wow. This will be a very painful video to assemble, but I'll do my best to kind of tell the story of how I got from where I started to where I am now. Yeah. Okay. Thanks for watching whatever it is I put together. I'll see you on the next video.